Hey students, ever wondered how ancient civilizations built magnificent structures like the pyramids? It all started with the fascinating concepts of surface area and volume. This magical branch of mathematics can help us to create our own masterpieces and solve real-world problems in design, engineering, and even space travel. Solid shapes are three-dimensional objects that have length, width, and height. For example, a soccer ball is a solid shape called a sphere. A cereal box is a solid shape called a rectangular prism. And an ice cream cone is a combination of two solid shapes, a cone and a hemisphere. Studying surface area and volume helps us understand and calculate the space these objects occupy and how much material is needed to make them. In this video we will study the surface area and volume of an important solid shape, cone. So let us get started with cone. Now, think about a cone, a 3D shape that looks like a party hat or an ice cream cone. It gets smaller and smaller from a big round bottom to a pointy top called the vertex. Let's explore the formulas used to calculate the surface area and volume of the cone. First, we need to understand the key elements of a cone. First, radius r, which is the distance from the center of the base circle to any point on the circle. Second, height h, which is the distance from the vertex to the center of the base circle, measured along the perpendicular line. Third, slant height l, which is the distance from the vertex to any point on the base circle, measured along the slant edge of the cone. Now, let's dive into the formulas. The curved surface area and total surface area of a cone are important measurements when trying to determine the amount of material needed to create or cover a cone-shaped object. Let's break down how these formulas were derived and what they mean in simpler terms. So, what is the curved surface area of a cone? Imagine you have a cone-shaped object, like an ice cream cone. The curved surface area refers to the area of the outer curved part of the cone, excluding the flat circular base. To find this area, we use the formula. Curved surface area is equal to pi rl, where r is the base radius of the cone and l is the slant height. Let us derive the curved surface area of the cone. Now imagine that we are cutting the cone open along its slant height and then flattening it out into a flat shape. This flattened shape will look like a sector of a circle with radius same as the slant height as the cone. The length of the curved edge of the sector will be equal to the circumference of the base of the cone, which is 2 pi r. The area of this sector is half the product of the radius, the slant height, and the curved edge, the circumference, which is 1 by 2 times L times 2 pi r, or simply pi rl. So, the curved surface area of the cone is pi rl. Moving on, let us study the total surface area of a cone. The total surface area of a cone includes both the curved surface area and the area of the flat circular base. To find this, we first need to calculate the area of the base, which is given by the formula pi r squared. Now, to find the total surface area, we simply add the curved surface area, pi rl, and the base area, pi r squared, together. Therefore, total surface area is equal to pi rl plus pi r squared, which is equal to pi r, L plus r. This formula gives us the combined area of the curved surface and the flat circular base, allowing us to determine the amount of material needed to create or cover the entire cone-shaped object. Now let us try a few NCERT questions to solidify our concepts. So the question is, it is given that diameter of the base of a cone is 10.5 centimeters and its slant height is 10 centimeters. Then, find its curved surface area. Let us denote curved surface area as CSA. So as we discussed earlier, the formula to find the curved surface area is pi times r times L. Here the value of pi can be taken as 22 by 7, where r is the radius of base of the cone and L is the slant height. Let us say the diameter of base as d. Here diameter of base, d, is given as 10.5 centimeters. Therefore, radius, r, is 10.5 divided by 2, which is 5.25 centimeters. Here, slant height, L, is 10 centimeters given in the question. Therefore, the curved surface area of a given cone is 22 by 7 times 5.25 times 10, which is equal to 165 centimeters squared. Hence, the curved surface area of given cone is 165 centimeters squared. Let us solve another question on the same concept from the NCERT textbook. Given that a joker's cap is in the form of a right circular cone of base radius 7 centimeters and height 24 centimeters, we have to find the area of the sheet required to make 10 such caps. The base of a cone-shaped cap is open, allowing it to be worn on the head. To find the area of the sheet required to make one cap, we need to calculate the curved surface area of the given cone. The curved surface area of the cone is given by pi times r times L, where r is the radius of the base of the cone, which is 7 centimeters here. But we don't have slant height, so we have to calculate it. Now it is given that the height of the right circular cone, say h, is 24 centimeters. Imagine a right-angle triangle whose base is equal to the radius, r, of the cone, which is 7 centimeters, and height is equal to the height, h, of the given cone, which is 24 centimeters. Therefore, the hypotenuse of this right-angle triangle is the slant height of this right circular cone. So, now we can apply the Pythagoras theorem to determine the value of hypotenuse of this triangle, which is equal to the slant height of the given cone. Therefore, slant height, L, is equal to under root of r squared plus h squared, which is under root of 7 squared plus 24 squared, which is further equal to under root of 625. After solving, we will get 25 centimeters. Therefore, the slant height of the given cone is 25 centimeters. Now we can calculate the curved surface area of the cone, which is pi times r times L, and the value of pi taken is 22 by 7. Thus the curved surface area of a given cone is equal to 22 by 7 times 25, which is equal to 550 centimeters squared. The curved surface area of one right circular cone, or the joker's cap, is 550 centimeters squared. Therefore, the area of the sheet required for 10 such caps is 550 times 10, that comes out 5,500 centimeters squared, which is our answer. Now let us discuss the volume of a cone. The volume of a cone measures how much space it takes up. To find the formula for the volume of a cone, we will take the help of a cylinder that you have already studied in your previous classes. Now think of filling the cone with water and pouring it into a cylinder with the same base and height. What did you observe? How many times do we have to fill the cylinder with the cone to get the cylinder completely filled? We need to fill the cone with water and pour it into the cylinder 3 times to fill the cylinder completely. Therefore, the volume of the cone is 1/3 the volume of the cylinder. The formula for the volume of a cylinder is pi r squared h, where r is the base radius and h is the height. Since the volume of the cone is 1/3 the volume of the cylinder, the formula for the volume of a cone is 1/3 times pi r squared h. Now that you have understood the volume of the cone, let us solve a question from the NCERT textbook. Question is, a right triangle ABC with sides 5 cm, 12 cm, and 13 cm is revolved about the side 12 cm. Find the volume of the solid so obtained. Now what is given to us? We are given with sides of the right angle triangle ABC where, let us consider 5 centimeters as base, 12 centimeters as height and 13 centimeters as hypotenuse of triangle. Since the right triangle is revolved about the side 12 centimeters, therefore the cone formed has height 12 centimeters, radius of base of cone is 5 centimeters, and the slant height of cone is 13 centimeters. We have to find the volume of the right circular cone formed. Let us denote the volume of the right circular cone as V. Now, as discussed earlier, the volume of a cone is given by 1 by 3 times pi r squared h. Therefore, the volume of the right circular cone is equal to 1 by 3 times pi times 5 squared times 12, which comes out to be 100 pi centimeter cube, which is our answer. You can also put the value pi, which is 22 by 7, to get the simplified answer. So volume of cone after putting value of pi is 100 times 22 by 7, which is further equal to 314 centimeters cube. So the volume of the right circular cone comes out to be 100 pi cm cube or 314 centimeters cube. Let us have a brief recap of what we have studied so far. The curved surface area of a cone is given by pi rl, where r is the radius of the base and l is the slant height of the cone. The total surface area of a cone is the sum of the curved surface area and the area of the base, which can be expressed as pi rl plus pi r squared. The volume of a cone is given by 1/3 pi r squared h, where r is the radius of the base and h is the height of the cone. Now that you have understood how to find surface area and volume of a cone, open the Edurev app where you get video lectures, chapter notes, and MCQ tests for this chapter to solidify your concepts. Edurev also provides you amazing courses for science, social studies, English, Hindi, and many more.